Okay, I know I said I was done talking about substitution, and hopefully you did go and do that homework, but I want to observe one more thing that's going to make our next topic easier. When you have a problem, like, say, cosine 3x, say I want to integrate cosine 3x, this is the type of problem that you would do a substitution on. I'm likely to do the substitution u equals 3x is a thing on the inside whose derivative is just 3. I don't have a 3 on the outside, but I can fix that. I would put a 3 here, and I would put a 1/3 here, and I would get 1/3 integral 3 dx all becomes du. I get cosine u. What's the integral of cosine u? The thing whose derivative is cosine is sine. What was u? U was 3x. I get 1/3 sine 3x. This is what I want to call a baby substitution, where yes, we did this by substitution, but like writing all this out feels like overkill, and we're going to be doing problems like this one in the middle of an integral by parts, so you want to be able to do a problem like this without this much writing. Like when this is the middle of a much bigger problem, you don't want to have to write out u is 3x and du is 3 dx. The thing I want you to be able to observe is cosine 3x. I want you to be able to look at a 3x and say, this is basically x. What would the integral of cosine be? I know the integral of cosine. The integral of cosine is sine. I want to say the answer to this is sine. And the thing on the inside of the sine is like a 3x. This is not quite right because I know how the chain rule works. Chain rule says derivative of sine 3x is going to be cosine, leave the inside alone, multiply by the derivative of the inside is going to be 3. So when I take the derivative, the chain rule is going to poop out a 3 that I don't want there. So I will put a 1/3 out front to deal with it. You want to be able to do this kind of integral in your head, this kind of little substitution right away in your head. And the rule, I mean, we could write down the formulas in general, that the integral of cosine kx, when you have a constant on the x inside, you get sine kx, and you need to divide by k. It's a little bit broader than that even. The really important thing is that his derivative was a constant. It could be kx plus c. Same deal works. You just need to divide by the k that's going to get pooped out as the derivative of the inside, as long as you leave the inside alone. We could write out rules for this, but I would need one for sine and for cosine and for e to the, like every integration rule. You can replace the inside, change it from an x to a constant multiple of x plus another constant, as long as you divide by that constant out front. Let me do a couple of quick examples of what I'm trying to say. What I mean is that if you have the integral of e to the 4x minus 8, that thing I want to say is, because the derivative of this is a constant, this is basically like an x in there. And the integral will be, what's the integral of e to this stuff? It's e to this stuff. Leave the inside alone. And I need to divide by that constant out front. That constant that will come out when I take the derivative is a 4. And it should be easy for me to take the derivative of this in my head. 1/4 e to the, leave the inside alone, times the derivative of the inside is a 4, cancels the 1/4, I get this. You want to be able to do something about that complicated in your head. If I have the integral of 5x plus 6 all to the 3/5, well, this is basically like the integral of x to the 3/5. I need to add 1 to the exponent and divide by that new thing. The place where I'm off is the derivative of this is going to be a 5. When I take the derivative, the chain rule is going to poop out a 5. I need to fix that with a 1/5. Now I just need to integrate that. I add 1 to the exponent. 3/5 plus 1 is 8/5. I add 1 to the exponent. I divide by the new exponent out front. I get 1/5 of 5/8. If you're really smart, you can multiply these two fractions together in your head. I'm not good enough for that anymore. I get this. The 5's cancel, if you want to simplify it. So that's the idea. When you have a thing on the inside whose derivative is a number, which basically means a linear function, you can do this, just divide by the thing that you're going to get out, and you don't need to write out the whole substitution. And in particular, you don't want to be writing out the substitution. You want to be good enough at this that we can do a problem as bad as this one in the middle of an integral by parts and not be freaking out about it. I do want to be clear that this only works for when the derivative is a constant. If I have the integral of x cubed, you're going to be tempted to say, well, it's going to be sine. Leave the inside alone, but I need to divide by what the derivative is. But you've done enough derivative problems to know that when you take the derivative of this is not a constant out front. The chain rule is going to happen, and you're going to get extra gross stuff that you don't want as part of your answer. So the key thing that makes this work is the derivative of the inside is a constant. And when I come back later and take the derivative of that constant, it just sits there and doesn't cause other problems. When the derivative of the inside is more than a constant, when it has x's in it or u's in it, whatever variable's going on, you need to know that you're not allowed to do this. You're not allowed to just ignore it. Okay, let's move on to integration by parts.